So, Mr. Frederic Rosat,
Mr. Sergio Ocon.
he's the lead architect for many things in SUSE. So perhaps.
Yeah. So I'm architect for next generation OS, mostly, and also for Linux containers. And Sergio is product manager.
I'm the product lead for what it was called ALP, and then it was called another thing, and then it was called, we call it Framework 1, and we expect that to be the last name. There is a new code base that is going to be the core of every SLS, SLE, and similar products in the future. So everything you see here is based on a new code base, and I'm responsible for that code base. And part of that is SLE Micro, the container application collection for Linux, and as BCI, and everything in the cracks and in between to work on that. So who was in our presentation yesterday? Who had the lucky thing? Okay, half of you. So you know everything about immutable systems. Great. Thank you. We are going to be talking about how to use. No, this is not what I'm going to. Yeah, they need. So what we're going to be doing today is we're going to think we are a small company that need to run WordPress, and we are going to use containers. And because we are small, we don't want to manage anything. We don't want to know what's going on. We want everything to be working all the time, update as it needed, and we're basically going to do that. I pay for WordPress for a third-party company, so yeah, I want to pay less, just having something running. And you're going to be seeing that, so many of the things, again, we chose WordPress for two reasons. One of them because it's WordPress, and 60% of the internet is also WordPress. But because it requires two containers, one for the database and another for the application. It's not too complicated, but we hope it's complex enough that you can get something out of this. If you have a laptop, you can follow along, like Disney sing-along, but you can do it with your command line. Unfortunately for you, Frederic is the one that is going to be working on that. So we are going to use a few components, not too many. The first one is Open Build Service. Open Build Service is a place where you can basically build your containers, your RPMs. It's a public version of the pipeline we use to build all our systems. So every time you see something from SUSE, it's built on the internal build service. And it was so good that we decided to make it public. And this is great because you can use it for your projects. The CNCF, for instance, every time you see Kubernetes, they are using OBS. So we are going to be using tools are available. You just go and grab them. And if you want that in a productized version, talk to me, because we would love to see if there are enough need in the market for that. The second thing we're going to be using is systemd Quadlets. And what is this? You will say, well, how many people know Quadlets here? Okay, 3 people.
4.
Good. So you can come and help with the demo then. But it's basically this is a way of running container managed by systemd. You tell systemd what they want to do, and it runs them. So you don't need an orchestration system. It uses systemd. It's not for big applications, but if you're going to run, for instance, a WordPress with a database as a container in a system, it's a perfect solution. And it's part of SLE Micro, it's part of SLS 15, and it will be part of SLS 16. Interesting things about that. It integrates with systemd, so we can use many of the tools that systemd provides. For instance, when you run a container, the logs will be stored in the system log, not inside the container. So you can run an application, you don't lose the logs when the application does, and also allows you to do up to days, and it has health checks, and it allows you to do rollbacks. So it's really adding that availability layer on top of everything you do. Because we're going to be using SLE Micro, we have Podman, so everything you will be seeing is not using the Docker daemon, it's using Podman. That it's a great solution when you don't want to have a daemon just to run a container. There's another side to this, and it's included in Slim Micro 2, that is Cockpit. Cockpit is a graphical interface that allows you to see what is happening in your infrastructure. So you can connect using port 9090.
Yes, SE Linux is enabled.
SE Linux, yeah. There's a very nice drawing picture book called, what is it, SE Linux. I don't remember the name. I have it and I feel it, but SE Linux is nice. We are using now that as a security in Slim Micro. It will be part of SLS 16 and all the other flavors. We moved from AppArmor to SE Linux, and it's there. There's one of the changes on the new code base is we are using Network Manager. The other one is we're using SE Linux. And now, because in SLS 15 and Slim Micro 5, you have SE Linux, but it's disabled. In the new version, it's enabled by default, and we have the policies required to be using. You don't need to create your own policies. They are already there.
And use the opportunity, if you have questions, raise your hands, ask them. Yeah. Don't wait for the end of the talk.
Yes, please. That was really, thank you. The other thing we're going to be used is base container images, and I'm not going to repeat this, but when you need to run containers and you want those containers to be safe, secure, updated, and going through all the process we have to make sure that your applications are at the level you need, we use BCI. BCI is right now built from SLE 15. We will have new BCIs that will be based on the new Framework 1 code base, and you will be able to choose between the two. But when you need that, and there's a lot of things, if you come tomorrow to the roadmap, you will learn about our ideas on how to expand BCI to more use cases. And now I look like Marvel. Every presentation I talk about the next presentation, so I can get you there. And the last component we have is Slim Micro, a SUSE Linux Enterprise Micro that is an immutable system. It's basically, we use transactional updates. It's a transactional and immutable system that is very lean and allows you to run containers. And it has some capabilities that we will be showing today. So I'm not going to go into detail of a Slim Micro, but because you are going to be falling in love with it at the end of this tutorial. And I don't need to oversell something that it's so beautiful. So that's all. I will get quiet. Sorry.
Thank you, Sergio. So we are going to do the slide deck exactly in reverse, because I'm going to show you first Slim Micro and then the things on top of it. So for the demo purposes, I have set up a VM. And all the deployment script, everything is already on GitHub. So if you want to look at that after the talk, feel free. If you have questions, you can find me on the Slim Micro booth later, or on GitHub. You just raise an issue, whatever. That's not a problem. So this is a Slim Micro 6, so based on SUSE Linux Framework 1. Code base. This is a Slim Micro 6. What the system is doing right now, it's booting and it's going to deploy immediately my configuration. So while it's doing that, it takes a few seconds. I'm going to show you exactly what is in the deployment. So for that, we use in Slim Micro ignition and combustion, which are a way to describe exactly some set of initial steps which will be taken during the first boot. So my ignition file is very small. I just want to set a root password, enable a few systemd services, Cockpit, because we want to use it here, and Podman. Again, we don't have to even have the Podman socket running, but otherwise, I would have some warning in Cockpit. And then what did I do? I set up the host name as a SUSECON container VM. So very basic stuff.
Most of you must be familiar with Cloud Init. This is another
This is the same kind of.
thing. It's ignition runs on first boot and configure some things. You can use combustion that will basically run a script, bash scripts in first boot, so you can finalize the configuration. We found it more flexible than Cloud Init, and also Cloud Init is huge and has a lot of dependencies. So
Yeah, Cloud Init pulls Python. So this is something we wanted to avoid if possible, because Python means a bit more on SliMicro default installation, and the purpose of SliMicro is to be as minimal as possible. So if we can avoid that, we try to avoid it. So that's why we have ignition, and in addition to ignition, we have combustion, which...
and I need to say, if you use the cloud image or you use the VMware image for SliMicro, Cloud Init is included. So you need it, it's there, just not by default.
This is something new with SliMicro 6. So in combustion here, in addition to my initial setup, what I'm doing is basically I'm registering the system, and I'm going to deploy a few of those quadlets that Sergio mentioned. I'm just fetching them from my GitHub account. Of course, there would be other ways to do that. You could have a tarball, etc. Here, I'm on purpose making something which is fetching from my account and then setting up everything. This is basically what has been running on the system. Let me see. It's deployed. So you see at the top, the thing you see is basically the curl commands which were run. And right now, we have the system configured, and we don't see that, but we are going to check. We even have the containers already running. So if I switch to cockpit here, and since it's a self-installation, it's going to complain about the SSL certificate.
Very secure.
And now I have cockpit, which is web UI that I can access to basically look at the system and do some kind of one-to-one management. But remember that the point of SliMicro is to be a self-healing, self-managing OS, basically an invisible OS. You put it somewhere, you set up your workload, either container, in our case, or VMs, and you forget about it. It's going to auto-update when there are new maintenance updates. If something goes wrong with the updates, if something doesn't boot properly, it's going to roll back to the previous state. You kind of run and forget. But forget, but still run securely. Because sometimes you run, you forget, and then the CVE piles on top of each other. This is not the case with SliMicro. So here we have containers which are already running. I have two containers, a MariaDB container and a WordPress container. So let's see how I declared those containers on the system. So switching back to GitHub so that you can see. So for the MariaDB container, what I did is I create a quadlet that I put in etc containers/systemd. And this file is very similar, as Sergio mentioned, to a systemd unit. So if you are familiar with systemd unit, so I'm going to ask, who is not familiar with systemd unit? Nobody in the audience. Perfect. So the first section, units, this is very familiar. The service section at the bottom, again, this is a few things I want to run for when the container is, before the container is even started. For my case, I want to create the directory where I will store the database information and make sure the SLinux labeling, we were talking about SLinux earlier, is done on this directory. And then the interesting part is the container section. Because here I basically describe what kind of container, so where do I fetch the image, how I configure the image, and how the container will be running. So in my case, I'm using the BCI image from the SUSE registry unmodified. So MariaDB, I tagged it at version 10.6. I set up a few environment variables. So yeah, root password. This is extremely secure, as you noticed. And it's on GitHub, so nobody knows about those passwords, of course. So I've set up an internal network for that. I bind it to the container names, and then I associate internal volumes in the container with the host. So in my case, what I'm only needed is varlib and MySQL. Then I had a few things which are very nice. I will show you that a bit later, which is auto-update and notify with some very nice tricks, which allows to have automated rollback and make sure that also the sequence of startup between containers is also respected. So this is for the MariaDB container. So let's quickly look at the, where is it? The WordPress container. This is kind of similar. The difference is I built my own container. This container is built on the OBS, so Open Build Service from OpenSUSE, and its associate registry. And if you want to see what is a container, it's a very, very difficult container to write, as you can see. We leverage again the BCI containers. We use a PHP Apache 8 container. And what I'm doing in it is I install PHP 8 MySQL bindings. I'm downloading the latest version of WordPress. This is obviously something you would not do in production. You would obviously make sure you speak a specific version of WordPress, etc. But for demo purposes, it was very easy. Just do a curl command with the latest curl, and then expand it and wrap that in a container. There is a small line to break the container. This is for the demo a bit later. So we have that running. We saw that in Podman, in Cockpit. So let's see, Podman PS, if I type properly. We have those, and we have also, which is something very nice, they are wrapped as systemd services. So if you are not into containers, but you still want to use containers, you can still do that and see them as services, like you would install them with RPM, except they are containers. This is very nice, and you use systemctl start, stop, etc. So this is really, really nice.
So how many of you has some application already packaging container that you need to run from a third party or internal? What does that mean? Not in production?
So
but
more looking into it, testing things, but yeah.
Okay, so you were waiting for this, basically. Okay, let me do that. I'm the product manager. I don't know anything. Okay. Or Rancher, that's okay. I like that. Yeah, this is for simple use cases. Yeah.
So I have okay.
Okay, don't look at the password.
Yeah, don't worry. It's not recorded for the internet. Sergio, they don't record us with a camera. They are recording directly my system.
I know. It was there for 1 minute before I raised.
So basically, you see that WordPress is already deployed with the container. It's just taking a few moments to do the installation of WordPress. But yeah, thank you.
Wow.
Everything I didn't mention, but I think it's probably obvious for people in the room. Everything is running on my laptop.
Is this?
And we have Suzocom demo, you can see at the top. We have our initial goal.
Yeah.
So now we have, again, 25 minutes. Let's try to break.
Destroy it!
Yes. Not my laptop, because my boss will not be happy if I take a hammer and I break my laptop. But let's try to break SliMicro, and let's try to break the container. So let's see what nice feature we have in SliMicro, which make it a very interesting OS for deployments and for running containers. What we think the best OS to run containers when you don't want those containers to be managed. Of course, if you want to have something managed with Kubernetes, RK2, K3s, Rancher Prime, you can install Kubernetes, RK2, Rancher, and K3s on top of SliMicro. They will work perfectly, but what I'm doing here is for the case where you want small containers, you don't have the big scale cloud native, container native solution. So here, let's try to break the OS first, because it's interesting. We have something which is called health checker in SliMicro, which is going to check when the system is booting if some of the basics health of the system are respected. And you can add additional plugins. You can write plugins, shell scripts, which is very simple. And what those plugins will do, if they do some tests that you write, and you can have two levels of mitigation. First one is, a service is not starting, let's try to restart it with systemd. And if it's really not starting, and it's the first time the system is booted with this state, let's roll back automatically to previous state, because SliMicro is an immutable system. It's a system based on transactional updates, which mean when we modify the system, we never modify the running system. We modify a copy of the system, and then we activate this copy by rebooting the system. So let's take an example. I have created two additional health checks. One is making sure that SSH daemon is always running. The other is make sure that Podman is always installed on the system. So let me show you libexec health check. Podman container. This is very, very basic. I'm just running Podman system info at the boot. And if it's something not responding, then it means the system is broken. For a container host OS, it's best to have Podman running and working. So by raise of hands, do you want Podman removed, SSHD removed, or both? You choose. Both.
Okay, raise your hand. Okay,
I think I heard
both.
both. So let's
Okay.
Open SSH.
Your manager was going to complain if we use a hammer. Can I use a hammer?
On me?
No, on your laptop.
Oh, okay. But it's still a good laptop. So here I'm running the equivalent of Zypper, except we are in transactional system. So it's transactional updates, PKG, RM, Opus SSH server, and Podman. So I'm going to install Cloud Init because it's a dependency, Podman, Toolbox, and a few patterns, and Open SSH server. So the system, but yeah, Zypper and transactional updates are fine doing this kind of crazy stuff. This is done in another transaction, so in another Btrfs snapshot. So which means right now I still have Podman is still on the system because I didn't switch to it. Question?
Wow.
Wow, this is interesting.
Oh, wow.
Let's try this one, and then we try it.
The question is, can we remove snap 2? And
that's a good question.
For those people without a camera, Frederick hesitated.
Let's try this one first. because I want still to make sure we show you something I validated, and then we'll try it. Okay, so let's reboot.
Oh.
Because I removed those packages, so the system is going to reboot. It's taking a few seconds. And if the system is rebooting,
Okay.
First boot, it's going to be fast because my laptop is still a bit fast, hopefully. You might see a bit of red, failed, up, it's rebooting again.
He didn't like Podman not being there.
So what happened is the health check run. It detected there was something wrong. It's a new snapshot. So this snapshot never passed the health check. And what happened is, and I'm going to go back in my terminal. Yeah, blah, blah. Quick. Sorry, I'm French, so half for my system is in French.
Oh, nobody realized.
Yeah, I try to hide it, but
Yeah,
not enough.
No, nobody realized. I think everybody's surprised. I'm Spanish, just for you to know. Nobody realized.
And Podman is still on the system. And status SSHD. SSHD is still on the system. So we had an automated rollback to a state we knew was working. So let's try to, because we like challenges and it's completely unprepared. So I'm not sure it's going to be accepted. Let's see.
No.
So now it's interesting because it's complaining that you are going to break your system.
Oh, break transactional update.
Because I'm crazy.
Do you have another VM?
No.
No, it's not allowing you to do that?
I cannot.
Ignores the one. No, it's not ignoring the one.
Break. Let's break.
No, it's asking every single time you ask. Okay. Transactional update, reboot.
So this is totally untested.
Reboot.
In the past, while it's testing, one of the things I really like to do to show the power of the snapshot and snapper was on SLES system to remove /USR. Was really like, I kill it, and I was able to roll back the system. Now with transactional update, it's a bit difficult. It was able to boot.
Has booted?
It has booted.
Because your check, it's on Podman, not on...
Yeah,
no, it doesn't,
let's see.
Doesn't make any sense. Who's the product manager for this? This is outrageous.
Dash Q. We can just do snapper, it was.
Snapper.
We don't have it. But we have a way to recover. So what is missing indeed is a check on the snapper presence. That's a good point. I will make a bug report and fix that. But we have a way to recover.
Yeah, I'm gonna open a Jira ticket now. Thank you.
This is live. So what I'm going to do is, until we fix it as a maintenance update for Slim Micro 6. The power of the snapshot is you have that. I can go back in time and add the grub level. So I can go back to the state of that boot. And we should get back to a system where snapper was, and then we can activate back this snapshot. Let's see. Yeah, it's complaining, but it's there. So we can just do transactional update, rollback, done. And then we have, the next time I reboot, I'm back to this state of the system. So even if the health check was not detecting that, we still can revert. Question? Yes, yes, sorry. So the question was, how can we identify the various snapshot because it's just numbers? So in grub, there was the time of the date when each snapshot was taken. And the thing that you can see is when you have snapper, you have this kind of list of each snapshots. And with snapper, you can query, you can access each snapshot, and you can even ask snapper what are the differences between one snapshot and the next. So it's always possible to do that. Snapper is extremely powerful. This is not something which is only available on SLI Micro. Snapper is of course available already on SLI 15. Back to my demo script, sorry. So we try to break SLI Micro OS. So far we failed. We almost got there with the help of the audience. Now let's try to break the container. So what I'm going to do, I have just copied my Docker file that I showed you earlier, which is wrapping WordPress in a container. I have it also on the system because what I want to do is basically build it locally, show you that it's still running, and then break it and try to auto-deploy it and see how the system is going to react. The way it's done is thanks to a feature of Podman, which is called Podman Auto Update. With Podman Auto Update, you can add a metadata to a container stating or giving the policy to Podman when the auto update trigger is run. So this is something you can configure. By default, it's every day around midnight. It's going to check if the container have a more recent version on the registry where they were pulled from, or locally. You have the choice. So if it's on the registry, it will do a network access. And if you are more in an air gap scenario, or you really want to control when you do those access to the outside, you can just manage yourself the container pool from the registry, and then it's going to just check on the local system. So here, I just built my container. Docker file. So this is again the container, which is a PHP Apache 8 BCI container, and on top of that, I just downloaded WordPress. Okay, Podman, auto update, dry run. What I'm asking Podman is, maybe I should switch to here because it's not really visible. So, okay. So it was Podman, auto update, dry run. Yeah, this is on the single line, it's more readable. So here you see that the WordPress services has a policy of local, so it's going to check locally, and there is an update pending. Obviously, I just built the container locally, and it has a more recent version than the one which was deployed earlier. So, okay, let's update it. Running, it was updated properly. Let's see, do we still have our container running? Yes, we still have Apache running. So now, okay, let's break it. So container, vi, Docker file, and I agree. I used a big hammer to do that. Sorry, I was a bit fast. I'm just making sure that Apache is not executable anymore in the container. So this way, I'm sure that this container will not start. So we have that. Let's build it. way faster because everything was already pulled. We have a new container. Let's do a dry run. Dry run, WordPress is still pending. Let's update. Oh, it's a big difference. It was not updated. It was updated. Then Podman tried to run the container. It failed. And it rolled back the container to the previous version of the container. So if we check, is our SUSECon WordPress instance still running? It's still running. So which means that with that, you can have an OS which is deployed, running, updating itself in the background. You don't have to deal with it. The updates which are pushed by SUSE will be, all the maintenance updates and security updates will be fetched automatically, applied. The system will reboot automatically on a maintenance window you define. By default, we do that at night, but it can be changed like every second day, or you can also monitor and trigger it yourself if you want. So on the OS level, we have this kind of checks and automatic updates. And at the container level, we have also this. You can have also this kind of checks where the container is going to be automatically updated when you make a new version available, or if it's an upstream container or a container directly from SUSE. Directly, you don't have to deal with it, like MariaDB, what I was showing you earlier. You don't have to etc container systemd MariaDB. Here, I just set it as auto-update registry. I'm using a pristine container from SUSE. I don't have to build it whatsoever. At any point in time where there is a maintenance update, a security update of MariaDB, I know my container will be updated from the SUSE PCI registry with all the maintenance updates, security updates, and I don't have to take care of it. To be honest, this is a bit of a drug, because when you are used to that, it's very, very difficult to come back to, I need to manage that differently. You kind of forget about it. You put it, you run, you let it run, and you forget it. It's a bit like the invisible OS or the self-everything OS. It's self-managed, self-healing. You don't think about the OS. You only think about what matters for you, which are your workload, being containers, being VMs. And I think I'm almost done with my topics. Yes, with my demo.
Yeah.
Question. Oh, tons,
okay. Yeah,
ton of hands. Yes.
I remember we have a phone. We have a microphone, so we can talk, and I don't need to repeat what you're saying. Funny thing about this, SliMicro is the core of a Rancher. So you update to Rancher, you are already using a SliMicro. It's just you need to install K3s or IK2, and then you have a Rancher cluster. So you can move from containers in isolation to containers orchestrated, as easy as installing something. And Suma manage SliMicro 6. So if you want to make sure everything is working and you want to have all the funny things and amazing things that Suma does, you just use it with SliMicro, and you still can benefit from all of this. So it's up to you to choose. So, the gentleman.
My question is systemd self-healing too? So, in example, if I remove the double point capital Z for the SE Linux, it shouldn't start the container anymore. Is that included in the self-healing, or?
Again, the self-healing is, we have a few basic tests. As we demonstrate, some tests might be missing, but this is always something which can be improved. I not 100% sure we have this kind of test on all the SLinux labeling. I mean, SLinux is enabled by default in not in permissive mode, but in restrictive mode. We make sure that the Podman and Docker and the virtualization stack will work out of the box with the policy we ship. After, this is not, the health check is not the panacea to cover all the cases by default, because it's very difficult to have something which is going to cover all the cases of all the customers. We could try to have 200 different health check plugins, but then maybe it would cause problem for half of our users. So we have a framework which is extensible, sorry, and this is because we feel that you know the best what you expect from the OS, and you can tune it to your requirements.
So you can create your own health checks to make sure that if this happened to you, somebody go and mess with SLinux because they didn't like it. After whatever thing you do, you can create a new health check to make sure it doesn't happen again.
Okay.
Thank you.
How can we see the reason for a fallback, a rollback?
Good question. So we can check if there was a reason for the fallback basically in the logs, because one thing I didn't mention, when we roll back, we don't roll back the entire system. We roll back the core of the system, which means we never roll back the logs. The logs are kept in the part of the system which is read-write, which is not read-only, and which is never rolled back. Basically, all your data. If you put a Rancher or Kubernetes cluster, a K3s cluster, it's going to be installed not on the core of the OS, but as an additional application, and it's going to be on part of the system which is read-write, which means the rollback, the snapper rollback, will not touch those data. Same for my example of the MariaDB. Obviously, you don't want the data, the MariaDB database itself, the data, to be handled by Snapper. You want to handle that with MariaDB dump or MariaDB backup. So /var, /srv, /opt, /home, or the root home directory, and what else? USR local, they are outside of the snapshot perimeter, which means if you roll back, they will stay like they were before the rollback. They will not go back in time. The only thing which is read-write, but with a bit of engineering and history, is /etc, because it's able to go back in time. For instance, you install something which is a brand new version of MariaDB, which have a configuration file which are completely different, and you want to go back in time. If you have edited the configuration in etc, you want to go back to the version of the config which was before. So we have this intelligence and heuristic, thanks to OverlayFS, to handle this thing. And back to your question, because I speak too much. Basically,
I can relate.
-u health checker. So I'm just looking at the health checker in the journal, and then I can see that earlier we had a Podman container which failed, so it's basically rolled back. So you can trace that in the logs. Yes.
Hi. I have two questions. I like this health check concept, but I don't like Bash. Can we do something else?
Yes, definitely. This is just an executable with let me take again cat user libexec health checker. We are supposed to be finished. Quiet timer. You did your job. So it's just, you just need to write any kind of executable. If you want to write it in Go, in Rust, whatever, just make sure it accepts the commands check and stop. Basically, and the only thing which is expected is the return code. So as long as you make sure that on the command line, when it's run, your plugins written in Go or Rust accepts the check command, and it has to return 0 if everything is fine, and 1 if something is wrong, and that's enough.
Okay, super. Next question, how do you automatically test this whole workflow before releasing to your customers?
Good question. So how do we test that? We have a tool which we make available to the entire community. You might have heard of it. It's called OpenQA. And this is the power of all the SUSE and open source distribution. And these days, it's even used now not only by us, but by other free software projects. So Fedora is using that. GNOME, with the Sovereignty Technology Fund from Germany, they are using that now also to test GNOME. So basically, we have a lot. So sorry, I cannot show the version of internal version, but if I take OpenSUSE Tumbleweed, for those who don't know, Tumbleweed is our rolling release. The big difference with a lot of the rolling release you have on the Linux ecosystem is every release is automatically fully tested, and it's only published if all the tests are green, or at least greener than the one which was released before. And so if you look at all the tests, we test a lot of things. We test containers. So we test that Builder is working, container is working, Docker is running, Helm is running, kubectl is running, etc. And if I just take one, let me see. I want to have something a bit. Yeah, we are in containers, so let's see.
One of the crazy ideas we have is to make this available to all of you as a supported service, because we know open source, open public services sometimes are not usable in your company. So if you have that requirement that you need open build service and open QA to build your own containers, to test them and make sure that everything is working, please come to the booth, talk to us. We will work with you to make sure that happens.
And so what I'm just showing is a speed run of the test, which has been recorded automatically. So we have a bunch of test cases which are available on GitHub. And we run that for not just, because you can always run tests with each component. The goal of OpenQA is to run integration tests, because that's the value of, you can pick any kind of software on GitHub or anywhere else. The goal and the work of what a company like SUSE and the community project OpenSUSE are doing is assembling all those components together so that they work together and don't break. And that's exactly the goal of OpenQA, is making sure that we can automatically test all those components with tests designed accordingly. For Podman, we are doing, we could check exactly what it's doing, but it's going to do Podman pool, try to run containers, etc., and make sure that they are always running, and we don't ship a new version of Podman or something else which is going to break the system. Does that answer your question?
Okay.
Great.
So is the time?
Yep. If you want to redo the demo at home or in your labs, everything is on GitHub. I tried to make it as this was what I used for the demo. I tried to write a good doc, but I'm not a good documentation guy. But I tried my best. If something is not clear, contact me and we can work it together.
Yeah.
Thank you for your attention.